what it does instead is it uses pattern matching instead. And pattern matching here is done by an expression that's called match with. Okay? And which looks kind of like a statement, except that OCaml doesn't have statements. All it has is expressions. Remember, it's a language where everything is an expression that gets evaluated to return a value. The easiest way to explain how match with works is, I think, to show an example. So that's what I want to do next. Okay, so I'll show an example about how, we got lots of them. So I'll show an example of match with. And then I can try to say something more general about it. So the example that I want to use is something that I call an association list. And this is not an OCaml term. It's actually a term that's borrowed from the programming language Lisp, which, if you remember, was one of the earliest functional languages. And so how a association list, well, what's an association list? It's a list of key value pairs. So if I have an association list, by the way, I'm going to abbreviate association list as AL. So the idea is that given a key, okay, I can find its corresponding value. So let me show an example of an association list. There's a lot of ways we could represent an association list, but what I want to do is I want to use a OCaml list and a bunch of tuples. So let's imagine that I want to have something here like a dictionary. And so let's say I've got okay, so I'm going to have an integer 1 followed by a string 1, and then 2 followed by a string 2, and then maybe 3 followed by a string 3. Okay, well, that's what I want to call an association list. And so the idea now is that if I can give the association list, or I can write a function that does this, I can have a function that takes an association list and a key, and it'll give me the corresponding value. So, my convention is going to be that my key comes first, my value goes like this. All right, so if I had a function here that could handle this, I could give my function this list and the key 2, and it would give me back the string with key WO inside it. Or I could give it a 3, and it would give me back the string with THREE inside it. And I could give it a key like 0, and then it would give me back an error. And it would say, you know, in effect saying, no, there's no such key in this association list. So this acts something like a dictionary, except that it's not particularly fast. We're going to use linear search to walk through the pairs of this list in order to search it. So it's not like a Python. It's not like a Python dictionary that probably uses hash tables and is really fast. It's going to have time proportional to the length of the list. Okay, does that make sense? Okay, now we could write this with head and tail and first and second, but I want to write it with pattern matching instead, because pattern matching is cooler. So I want to write a function called AL_get. AL for association list. And I want it to have 2 parameters. It has a list of pairs. That's my association list, so I'm going to give it something like this. And a key, that's something like so. Okay, and I want to use an internal helper do all the work for this function. And so my usual convention is that I'm going to call my internal helper AL getting, because what I like to do is stick ing on the ends of a main function to get the name of the helper. Key is never going to change, but pairs will. So I'm going to just have the internal helper inherit key, and I don't need to pass it around. That makes sense so far? Okay. Now, here's where we're going to see something you have not seen before. All right. I can say match pairs with, all right, and this introduces a match expression that contains a series of rules that are controlled by patterns. All right, and what will happen is that the first rule will try to match whatever pairs is, whatever appears after the word match. And if it succeeds, it will execute some code. If it fails, it will go on to the next rule. And if that rule fails, it will go on to the next rule and the next rule and so on. So I can have as many rules in a match with as I want. Okay? This will maybe become clear with an example. Okay, what happens if I have an empty list? Well, look, I'm searching my association list for a pair that has a key in it. But if I have an empty list, it means there are no pairs, and so I can't possibly find it. So I want this rule to indicate an error somehow. And so a rule is written using a minus sign and a greater than. It looks kind of like an arrow. Now, here's my chance to complain about OCaml's syntax. You remember, OCaml also uses the same arrow notation to talk about a function type. This arrow has nothing to do with a function type. So it's using the arrow in two different ways, and we will see later that OCaml actually uses arrow in yet a third way that has nothing to do with this. Don't blame me, I didn't invent this language. Okay, well, what happens if we get an empty list? I want to indicate that an error has occurred. And so, what I can do is, OCaml has an exception mechanism that it is kind of like it's kind of like the catch and throw mechanism in Java, or the exception mechanism in OCaml. And so what I do is I say raise and then the name of an exception. And what will happen is that OCaml will take that as an indication that an error, in this case called pairs error, has occurred. And I have to define pairs error before I can use this. So outside my function, I have to say exception pairs error. And these begin with uppercase letters. Okay? All right. The exception mechanism is a little more complicated than that, but we will, for the time being, this will get us where we need to go. Go ahead.
You need to put an exception and then a different error and help the let for every single type of error that we include.
Basically, let me answer the question in a little different way. I have to define every exception before I can use it. Okay, so again, OCaml has strict define before use. And let's just hold it there for the time being. Other questions? Okay, well, this isn't very interesting. All we did is we just detected an empty list. Let's see if we can do something more fun. So I'll write a pattern here. It's called other key, other value. Whoops. Other value. And other pairs. here's my arrow again. Okay, this is a pattern. What does this do? Well, the first part of the pattern is a two-tuple. And it's saying, all right, I'm looking for a two-tuple whose first component is other key and whose second component is other value. Okay? And so if, all right, and where does that two-tuple appear? It appears as the first element of a list. How am I telling it that? Because I'm mentioning this constructor here, the 2: constructor, and the rest of the list. So this is going to be the first element of my list. The rest of the list is going to be called other pairs. So what this pattern says is, it's saying the following: look at pairs. See if pairs has a first element that is a two-tuple whose components are other key and other value, and if it also has the remaining elements that are called other pairs. If it does, it will sort of break pairs up into those three parts, and I can use those parts in code after the end. So I got about a minute left. I probably won't be, may or may not be able to finish this. Well, let's go with it anyway. So what's the code that gets executed? Well, I'm going to test if key is equal to other key. If that's the case, then I have found the pair that I want. Remember, I'm doing linear search throughout the list. What do I want to do? If I find it, I want to return other value. What if I don't find it? What if key is not equal to the key I'm looking for? Then I want to continue searching. So I'm going to call ASL getting on other pairs. And the pattern has told me that those are all the pairs other than whatever is the first one. Okay, rules are separated by these vertical bars. And finally here at the end, and we have just a few seconds left, so we'll probably pick this up later, next time. I'm going to start my function off by doing that. Okay, so the idea here now is that I'm using a pattern to break up this list of pairs into pieces, and then look at the pieces and decide what to do as a result of looking at them. We really have time for one more question if somebody has one. Otherwise, we're going to